Hello, AP Stats. This is a Chapter 6 review video once again, but this is the second review packet that I passed out to you. And there are only 10 questions, and a lot of us did this during class today. We have finished probably all the way down to, most of you guys finished down to 4 or 5, but I'll still provide you the detailed explanations for each and every single one of these, and hopefully this will help aid your studying for the test on Thursday. So for number 1, the number of sweatshirts a vendor sells daily has the following probability distribution. And so for this, we want to find out the expected daily total dollar amount. Now that's very simple because if I want to find out the expected value, in a given table setting, it's best that we just use a table. So I'm just going to go here, clear all of my lists out, and then type this in manually. So 0, 1, 2, 3, 4, 5, and then type in 0.3, 0.2, 0.3, 0.1, 0.08, and 0.02. And then stat calc, one var stats with all of those things. And then I get the expected value to be 1.52. That's the expected number of, the sweatshirts that you expected to sell. But it's the price, which means I take 1.52 and multiply by the $25 that I'll be earning. So the correct answer here should be $38, as you can see in the calculator. All right, number 2, an urn contains exactly 3 balls, 1, 2, and 3. So those are the 3 outcomes that I could potentially have. Then I pick one, and with replacement, I pick the second one. Then I take the average of those two, where x1 and x2 are the numbers. Which of the following describes the sampling distribution? So if you take a look at all of those numbers, like where in the world are these two coming from? Well, those two are coming from when you take, let's say, the first event, you choose ball number 1, and the second time you choose ball number 2, and when you average them out, you actually get 3/2, which is 1.5. So these values are possible. Now, what's a chance of you getting 1 is really the main issue. The chance of you picking the first ball is 1 out of 3. The chance of you picking the second time, 1, 2, 3, out of those, you pick the same ball is 1 out of 3. Why? Because you replaced it. Your chances are independent, they're the same. And for both of these two events to occur, one after the other, you have to take these two events' probability respectively and multiply them. So the chance of that happening, that you get a 1 and ball number 1 on the first try and ball number 1 on the second try is 1 out of 9. And the only choice that contains that is B. Now, why the chances have changed? Well, that's because there are multiple ways in which you can get 1.5. So in this particular case, you have 2 and 1, or you can have 1 plus 2 or 2 plus 1. So there are 2 different ways in which you can actually get an average of 1.5. What I mean by that is if I were to draw a chart, 1, 2, 3, 1, 2, 3, and just sum them up. 2, or actually, why don't I just give you the average value? So add these 2 and average them. That will give me 1. Average these 2, which is 2 and 1. That should be 1.5, 1.5. This should be 2. That's 5. And that's 6, which is 3. So these are the average values when you add those two numbers up respectively. And you can see just how many times just 2 occurs in that long diagonal. So this means I actually have to multiply the same probability 3 times. So that's why it's 1/3. Then you have it twice, so it happens 2 times with the same respective probability 1/9, so it's 2/9. And so that's where all the numbers are coming from, basically. Number 3, y minus x, the mean is always subtracted. So because we're going from y to x, we're doing 9 minus 10. So the mean should be -1. Remember, the standard deviation never ever changes in terms of their formula, even if it's a minus sign in between. So that should be square root of 3 squared plus 4 squared, which is 5. So the answer is C. Number 4, a game of chance is played in which X, number of scored per game, has a distribution shown above. So choose for the sampling distribution of the sum of Y. So the sum of Y, again, I can draw myself a chart. Let's add them up. 0, 1, 2, 1, 2, 3, 2, 3, 4. It seems to me that all the possible events is 0 through 4, not just these three numbers. So I'm going to eliminate A, B, and C. Now, between D and E, y takes on values 0, 1, 2, 3, 4 according to a binomial distribution with the mean equal to a2. Now, because it's a sum of the two, the binomial distribution means you really have two outcomes, but it seems to me that you really have more than you have multiple outcomes here. So binomial distribution is not the best way to describe this. With respective probabilities, 0.09, 0.24, yes, E is the correct answer. And again, where are all these numbers coming from? Well, take a look at how many times 0 occurs. And in order to get a 0, you have to get a 0 twice with a chance of 0.3. And with this chance of being 0.3. And remember, always multiply the probabilities because they're independent events. That gives you 0.09. Now, the second one being ones, that happens twice. And the chance of that happening here is 0.4 times 0.3. So that's 0.12. And then you can have 1 first, then 0, or 0 first, then 1. So you have to double it, which gives you 0.24. It happens twice. You can see that on the map too, that the 1 happens twice like that. But anyways, E is the better choice, or it's the best choice. Binomial distribution makes no sense, and E is the correct answer for 4. Number 5, the probability of obtaining a head when a certain coin is flipped. So it's not a fair coin. Which of the following is closest to the probability that heads will be obtained 15 or fewer times? Binomial CDF, everybody. Chance of success and failure is nicely provided. N is fixed. And we want the value to be 15 or fewer. Second vars, and then binomial CDF. I believe the trial should be 25.65. Oh, I'm sorry. We want to have heads will be obtained 15 or fewer times, so that should be 15. Yes. And so the answer here should be 37%. Binomial CDF question. Number 6, the number of points scored in a game has the probability distribution below. The number of points obtained in a game is independent. We have 0, 1, 2, 3, or 4. Those are all the possible events. Y represents the sampling distribution of the sum. Once again, they want you to add them up. So if you were to draw the map one more time, 0, 1, 2, 1, 2, 3, 2, 3, 4. Let's take a look at each and every single respective probabilities here. So the chance of you getting 0 and then 0 again, it's 0.4 times 0.4. So this happens 0.16% of the time. So what I can do is I can write down x with its respective probability. 0 is 0.16. Now for 1, it happens twice, and it's where you get 1 and then you get 0, and vice versa. So that's 0.3 times 0.4, which is 0.12, and then another 0.12, so that's 0.24. For 2, I can have it two different ways. I can either have 2 first, then 0, which is 0.3 times 0.4 again, which is 0.12. Then you can have 1 and then another 1, right? So you can have the 1 and then the second one also being 1. That's 0.3 times 0.3, which is 0.09. Then you have the third one here, which is going to give you the same probability as the one you found up here, the same as 0.12. So when you add these three numbers up, it should give you 0.33% of the time. Now, when you go down to 3, yes, it only happens twice, and there's really just two options here. You either get 2 and 1 or 1 and then 2. So the chance of that happening is these two multiplied together, 0.3, 0.3. So that's 0.9 plus another 0.9, so it's 0.18. And I think it's clear as to what is the clear winner. 2, it has the highest probability here. Number 7, a company sells concrete in batches of 5 cubic yards. The probability distribution of X, okay, I'm given a table, and they give me a standard deviation and mean. Lovely. So I don't have to type that into my list and do stat, calc, all that good stuff. What is the standard deviation of Y? Well, Y is 75 times X minus 100. Now, remember what minus 100 to the data does in terms of standard deviation. It actually has no impact. Adding or subtracting, the only thing that changes is the center. Well, we're talking about the standard deviation. Multiplying by 75, that definitely changes the standard deviation by a factor of 75. So You take the standard deviation and you multiply by 75 because it just simply gets multiplied by that amount. So the answer here should be B, $432. A nonprofit organization plans to hold a raffle to raise funds. So 1,000 raffle ticket will be sold for $1 each. Okay. After all tickets are sold, one ticket will be selected and its owner will receive $50. The expected value for the net gain for each ticket is negative 0.95. What is the meaning of the expected value? So the expected value means that on average, every turn, you're going to lose 95 cents. That is the answer B. The ticket owner will lose 0.05. Nope. It's the actual amount of the expected value, which is B. I will go through the rest of the answer choices just to help you guys out. C, each ticket owner will lose 0.95 per raffle ticket. That means that by no matter what, you're going to lose 95 cents per ticket. But sometimes you can maybe win that $50. Maybe your loss is $1 each time. This is talking about at that one particular instance, you will lose 95 cents each time. The word they're missing is obviously the word average. Okay, so between C and B, B is the clear better choice here. Even though they're kind of talking about the same thing in a way, but B is the better way to put it because it has the word average. The ticket owner would have to purchase 19 more tickets for the expected value of his or her net gain to increase to $0. So the number 19 is coming from for the fact that if you were to purchase 19 more tickets, this will negate to $0 because technically speaking, if you just purchase 19 more tickets, assuming that each of them are worth about 5 cents each, because what you have is 1 out of 1,000 chance of you winning this $50. So that is your sort of like your revenue. That's the money that you're probably going to get. And when you do that, you get about 0.05 or 5 cents. And you can think of that as your expected value of gain, but this does not accommodate for anything that has to deal with this, $1 each. When you purchase 19 more tickets, that means you're losing $19 too. So how is the net gain going to increase to $0 when you're losing 19 bucks? Makes no sense. A ticket owner has a 95% chance of having a ticket that, okay, that 0.95 is not the same as 0.95 in terms of percentages. It's the dollar. So it's 95 cents, not 95%. E is complete garbage. So answer choice B is the correct one. Number 9. Ooh, free response. What is the probability that at least one ATM is working when the mall opens? Guys, this is just going back to chapter 5. It has nothing to do with chapter 6 materials. It's just testing you to see if you know conditional probabilities and things like that. Working when the mall opens, at least one means these three all put together is 0.85. What is the expected value of the number of ATMs that are working when the mall opens? So you can do 0 times 0.15 plus 1 times 0.21 plus 2 times 0.4 plus 3 times 0.24. Or, yes, or you can type this into your calculator. Absolutely. So stat edit. So 0, 1, 2, 3. 0.15, 0.21, 0.4, 0.4, and then 0.24. All right, so stat calc, one var stats, and you already know. It's going to be 1.73. That's the expected number of ATM machines that's to be working at the mall. What is the probability that all 3 ATMs are working when the mall opens? Given, hey, conditional probability, given that at least one ATM is working. So it's kind of like when X is all 3, given that X is greater than or equal to 1. So what that means is you want to find out the probability of X is greater than or equal to 1 and put that as your denominator, which is answer choice A. Now, what's your chance of all 3 of them working? Well, that's just this column right there, 0.24. So 0.24 divided by 0.85. I'm just going to use my calculator here real quick. That's 0.2823. All right, so for part D, so given that at least one ATM is working when the mall opens, would the expected value of the number of ATMs that are working be less than or equal to or greater than? So what we're saying here is that for this table, we're eliminating this. Now that 0.15, well, 15%, that has to be redistributed to these 3 columns somehow, because you know the valid probability model says that these three has to add up to 100%. Now, if the 0 is out of there, then you only have 3 possible outcomes with 1, 2, and 3, and each of these probabilities will increase in some proportional amount. What that means for us is that the expected value that we found, notice how this one just gave you straight up 0, and you're really just adding 1, 2, and 3 values. Now, you're just still going to do 1, 2, 3 values to find out the expected value for part D. But like I said, this probability, that probability will be very different from the ones you have in the table because they all have to increase to accommodate for that missing 0.15. So that will give you an example. Like it originally started with 0.21, 0.4, and 0.24. Like I can give 0.05 here, 0.05, 0.05, just equal amount shares distributed, which will increase this to 26, 45, and 29. Now, when you add these three, it gives you a valid 100% probability distribution model. And when you multiply the 1, the 2, the 3 with its respective probabilities, obviously the expected value will go up from 1.73. So the answer here, it's greater. All right, last question, part number 10. The graph below displays the relative frequency distribution of X. According to the local law, holding more than 3 means these guys. What is the probability that a selected household will be in the violation of this law? So let's add all these up. That should give you 0.17. So that's it. If 10 households in this area are selected at random, so n is 10, what is the probability exactly 2 of them? Now that sounds like a binomial PDF to me because I want exactly 2. But for binomial PDF, we got to check for bins, right? So let's do that. Binary outcome, violation or no? Violation, yes/no. So we have 2 outcomes. You're either in violation or not. Independent. Well, independent and same probability, like I said, they really go hand in hand together here. And for independence, you really have to use the assumption that the capital N times 0.1 has to be greater than the lowercase n. Remember, lowercase n here is only 10. Now, n represents the number of the dogs and the cats here, I believe, or the probabilities that more than 3 pets. We're talking about each household. So do we have evidence to believe that there's actually more than 100 households in here? How did I get 100? You guys know, divide the other side by 0.1 or just add the 0 at the end. Now, when you do that, is there a good enough reason for us to believe that there's more than 100 households? Yes, absolutely. So therefore, independence can be assumed, and the same probability here in violation is 0.17 from part A. Number of trials is fixed, like I said. So we're going to do binomial PDF of number of trials, chance of success, or chance of violation in this case, and we want 2. So I'm going to go to my calculator, so I'll show you guys what exactly you should be seeing. So second var's binomial PDF, and then trials should be 10.17, and that should be 2. And the answer here should give you 0.29291, so 29% of the time. And I believe the answer key also, yep, had the same thing right there. Okay, so hope this video helps for the second review packet, and make sure you look at the FRQ video as well. I'll see you guys next week.